So if you get across a problem like this, where they're looking for the roots of the quadratic equation, you shouldn't be scared. Lee got you. So the same thing, we should write down the two values of k for which the root of this equation will be rational, right? So they said that they've given us like the range of the k values. So they're saying that k is an element of integers from -3 to 3, right? So those are the only values of k that we have as options, all right? So the first question says that we must write down the two values of k for which this whole thing will be rational. So for this whole thing to be rational, for the value of x to be rational, or the root of this equation to be rational, everything that is inside the square root has to be a perfect square, right? So remember, rational means that everything that is inside the square root has to be a perfect square, right? So we're gonna make sure that everything that is inside the square root is a perfect square. So we got 20 plus 8k in the brackets, I mean like in the square root, you know what I'm saying? So now we have the range of values of k. They're saying that k is an element of integers from what? From -3, don't mind my handwriting, all the way to positive 3, right? So we're gonna put on the values of k. That's gonna give us a perfect square, all right? So the biggest value that we can have inside the under the square root here is, if you put -3 here, the biggest or the smallest. Okay, let's start with the smallest one. If you put -3 in place of k, we're gonna have 8 multiplied by -3. That, how much is that? That's -24. So -24 plus 20, that's -4. So that means that -3 does not work. What about -2? For -2, we're gonna have 8 multiplied by -2. That's -16. So 20 plus -16, 20 minus 16, that's 4. So -2 works because it gives us 4, and 4 is a perfect square, right? Then what about -1? If you put -1 here, 8 multiplied by -1 is -8. 20 minus 8 is 16, and 16 is a perfect square. No, I'm sorry about that. If you put -1 here, we got 8 multiplied by -1, that's -8. I'm sorry about that. 20 minus 8 is 12, and 12 is not a perfect square, so -1 does not work. What about 0? If we put 0 here, we have 0, 20, it's not a perfect square, so no. What about 1? If we put 1 here, we're going to have 28. If we put 2 here, we're going to have 36, and 36 is a perfect square, so 2 works. What about 3? For 3, we have 8 multiplied by 3, that's 24. 24 plus 20 is 44. 44 is not a perfect square, so 3 does not work either. So we only have -2 and 2. So that means that k is equal to 2, or k is equal to -2. So these are the only two values of k for which this whole root will be rational. So the second question says, write down one value of k for which the root will be non-real. So for the root to be non-real, everything that is inside a bracket, everything that is inside the square root has to be negative or less than 0. Because if you have anything inside the bracket that is less than 0, that means the whole thing is undefined or invalid, right? So that means whatever that is inside the brackets, which is square root. When I say brackets, I mean square root. I'm just used to saying brackets. Anyway, 20 plus 8k, which is something that is inside the bracket, has to be less than 0 or negative, right? So if we solve for this, we're going to have 8k is less than -20, right? So dividing both sides by 8, we're going to have k is less than negative. If we divide 20 by 8, we have 10 over 4. We have 5 over 2. What is 5 over 2? 5 over 2 is 2.5, right? Or you can just divide both sides by 4. So 4 into 20 goes 5 times. 4 into 8 goes twice. So 5 divided by 2 is 2.5, and we have negative on the beside it, so k has to be less than 2.5. So they're looking for the value of k for which this whole thing will be non-real. So k has to be less than this. That means k is equal to anything that is less than 2.5. So we start with -3, and because the values of k that we're given here is -3 to +3, -3 is the only option that we have. So that's how we solve this. So these are the solutions here. So next time you get across a problem like this, don't be scared. Just call me. I hope you have a great day.